Okay, so we've done basic trigonometric equations and we're going to look at trigonometric equations that have compound angles. There are two different types of compound angles. This is the first one that we have here, which is solve 5 tan 2x equals 3, and I will do an example of the second kind as well. This one can come up at National 5. It's like right at the hardest that you kind of see at that level, so you may have seen this before. Right, so our steps for solving this are pretty much the same, so we're going to rearrange so that the tan or the trig function is alone on one side of the equation. Right, so in this case, that means we've got 5 tan of 2x equals 3. When we're doing this, we're treating tan of 2x as 1, that's the tan function. The trig function is tan of 2x. And the 2x, there's nothing we can do about it at the moment. We'll get to how we're going to deal with that later. So we're going to get tan of 2x equals 3 divided by 5. Okay, because we divided both sides by 5 to get that on its own. Right, so once we have that, we just solve as though it was like tan of x. Or like a regular trig function. Okay, so we need to find our relative acute angle and we need to work out which quadrants it's going to be in. So if we go back over here, we have our cast diagram, or Amanda says trig's cool if you want to think of it that way as a way to remember it. Right, so tan is positive, and so that means it's going to be our first and third quadrant. And our relative acute angle, or angle for the all, is the inverse tan of 3/5, which when we round is 31.0 degrees, right? So we take this and put it back in over here, so that's going to give us 2x is equal to our first quadrant is going to be 31.0 degrees. Our second quadrant we don't need, our third quadrant is 180 plus 31.0 degrees. Okay, and because we're finding this between 0 and 360, we're probably going to have to end up with some more answers, because if we think about it, that tan of 2x means that in 360 we're going to have up to 360 there are going to be two tan graphs. So if we look like that, when we've got it equal to 3/5, we're going to have 1, 2, 3, 4 answers. So we need to have 4 answers for the 2x, and then we're going to find x after that. So we're going to need to do 360 plus 31.0 and 540 plus 31.0. Because as we go round our graph, we're going to get extra values. So we're going to get 31.0 degrees. We're going to get 211.0 degrees. Nope. Yeah, 211. We are going to get 391 degrees, and we are going to get 571.0 degrees. Okay, so now that we've found our 2x, we can find our x by just dividing all of these by 2, which gives us 15.5 degrees. It gives us 105.5 degrees. We get 195.5 degrees, and we have 285.5 degrees. Okay, so once we've solved it as though it was a regular trig function, this one we divide to find x. Okay, so that's how we solve when we get functions that have a 2x or a 3x. It's exactly the same, just you have to divide by 2 or 3 depending on what it is, and be careful to make sure you've got all the answers. So think about the graph and how many answers you would have within the range that they give you. Okay, so second type of trig function we're going to do next. Okay, so this is our second type of compound angle, and this is the bit that makes it different, the x minus 60. Okay, but our steps are very similar to our previous one. We are just going to go through solving this as though it was just cos x on its own, and then it's later that the different steps come in. So we're going to divide to get cos of x minus 60 degrees equals the square root of 3 over 2. Okay, so then here we go over to our cast diagram. So it's cos and it's positive, so it's going to be those first two, the two that I've ticked, which are the first and the fourth. Okay, and then our relative acute angle is the inverse cos of root 3 over 2. Right, and the root 3 over 2 we know comes from our triangle 1, 2, root 3. And because it's cos, that means it's the little one, so we get our 30 degrees. Right, so that means we have x minus 60, and that's going to be equal to our first quadrant gives us 30 degrees, and our fourth quadrant gives us 360. Take away that 30, so we get 30 degrees and we get 330 degrees. So that's what x minus 60 is equal to. So we have to add 60 to both sides. So we're going to get x is equal to 90 for our first one. And our second one, when we add 60, we are going to get 390. Okay, and that 390 is out with our range. However, if we think about just a cos graph in general, again, always linking this back to the graph, if one wave is in that 360 degrees, we're going to have two answers for our root 3 over 2. And we know that our wave just repeats every 360 degrees, so we can take away 360 degrees from this second one that's over our value to give us that we would have 30 degrees as well. Okay, so this is something to note for, that if your value is over your range, then take away 360, range, subtract 360, just to make sure that you've not missed a value. Okay, and if it's under your range, so if you get a negative, then you have to add 360. So you might get there if you've got x plus 90, for example, or x plus 200 and something. It could be any value, that if you get a negative here, if you add 360 to it, it'll give you the value within your range, because because of the way that the wave function works, it repeats every 360. Okay, so that is compound angles. If you want any more examples, let me know. And coming up next are solving trigonometric equations that are quadratics.